called in-class printf.bash. So this activity that you're going to need to do today, once I cut you loose, is I am teaching you, or I don't know if I am, I've structured this such that you learn more about the formatting codes in printf. If you're not familiar with printf is a function basically the workhorse function, whereas cout would be the workhorse in C++. Printf was the workhorse function in the C language, and ends up having some nice formatting capabilities. Due to its nicety, it has also been made available as a command that you can type. So in order to do this in-class exercise, you will either want to read the man page here. It's a little brief. It's too brief. What does it say about the information? Probably to do this in-class assignment, we would want to go to the web and type printf format specifiers, something like that, and find one that suits you. Probably that's not the best one. It's more of a reference in a tutorial. But anyway, let me look at it. So the way printf works is that you provided a string to print out. So I can say printf, hi there. And this is fairly similar to echo, except echo automatically puts a new line, so I'd have to put in a new line manually. So that's all fine and good. That formatting code can be a string, it can be an integer, either %d or %i works. D stands for decimal integer, so I think I is more intuitive. For whatever reason, early references on printf always use D instead of I, so that's ingrained in my head. And what follows this format string, a combination of literal characters and format specifiers, is a list of arguments that go into the specifiers. So if I had two of these, then I would need two arguments then to correspond to the two specifiers. So the specifier is %, obviously followed by a letter. S is for string. So if I had a string here, then that would get inserted in that place. String, integer, float. You can get like hexadecimal numbers. There's a whole bunch of codes. But certainly three of the most popular would be string, integer, and float. Looking at this, what I've given you are a bunch of challenges. So I've got these variables here, a name, value 1, 2, and 3, which is a float, two floats, and it looks like a negative number here, negative integer. Here, this is just asking you to print out this, print out the name variable. So it'd be these arrows with the name in between there. So that's pretty straightforward, and that's shown for you. Note that so I'm using variable substitution for the shell. Note that I do have this in quotes. If I don't put this in quotes, then it would take this as two separate values because there's a space there. So in general, you're going to want to ensure that all of your variables are in double quotes here. So then it's asking you to do another one, but put it in a field 20 spaces wide. I can show you how that looks. Let me see, what if I run this? All right, so it's got a few values in there. It looks like here, whoops, and in a couple places lower down. So what I would do in order to do this is Copy and paste that, and then to get 20 spaces wide, I'd look at my reference and go, okay, if I put the number 20 there before the S, that will put this in a field of 20 spaces. So run it up here. And there it did it. Next, it's asking you to do it in a field 20 spaces wide, but left justified by default. It right justifies this when it's in a wide field. So I'll give you that. To left justify this, I put a negative sign in front of it. So percent negative 20s means print a string left justified in a field 20 spaces. And we can see that it indeed did that. So that's what you're being asked to do for this. You just march through this, doing each one. I will say that this actually is the this one printf here actually prints all three of these, and that's an interesting quirk with the way this printf is processed. If there's one format code here and there's more than one argument, then what it's going to do is it's going to repeat this entire format string for each of these arguments. And that's precisely what we see here. We can experiment that real quick. Let's do this one right here. If I was to put, say, a second one here, so I put another one, then we'd expect to see value 1, then value 2, and then let's see what it does with value 3. So there's value 1, there's value 2, and then there was still a third argument. So it prints this entire format string all over again. That third one goes in here, which is what we see right here. That's a -2. Recall that I wrote -2 as an integer, but the format code is for a floating point number. So it prints that floating point number, and by default with floating point numbers, you get 6 spaces of precision. Of course, there are modifications to that, right? I can put information between the percent sign and the F in order to change, for example, the precision. And then there wasn't a fourth argument here, but it was already committed to reprinting this format string. So this one just took a default value of 0 to fill in that missing argument there. So there's that. And other than just being very handy, you can do some fairly tricky formatting in a very compact space using these specifiers. So it's definitely worth getting to know that. So that's why I have that assignment. A secondary reason for the assignment is because today we are going to talk about awk. And I've got a file, a few files to save time that have went ahead and thrown together. This file here, what is this? It's called awk format.awk. Awk is, I don't think I've used this term before, but this applies all these Unix tools where I'm saying the standard in and standard out. Those are what are referred to as filters. So it just filters information. And awk is a tool that is also a filter from standard in out to standard out. Although, like a lot of these filters, you can specify files and so forth. What awk is it processes text like sed does, that stream editor, except it's a little more programming language-esque. And let me use this as a guide. I up here showed you the reason it's called awk. It's because it is the first letter of the last names of the 3 people who created the tool. Aho is real big in compiler circles. Weinberger, I don't recall what he's doing nowadays, but he's also well established. And Kernighan's claim to fame is that he was one of two people involved in the creation of the C language. And what were all three of these people doing together? Just the 30 seconds of history. Back in the 1970s, AT&T was in essence a huge telephone monopoly. AT&T was what provided not only your long distance service, but also your local service. And now we've got, well, even let's see, all these traditional telephone companies are starting to go the way of the dodo with all the cell phone stuff, but you have Pacific Bell, I don't know, Atlantic Bell, all these, they're called baby bell companies. Ultimately, AT&T was so big and such a monopoly that Congress forced them to split up. AT&T still exists, but only as a long distance company. And all of its local service got split up to little different sub companies. Anyway, the reason I bring this up is that AT&T during those days when it was such a huge concern had a research arm, and that research arm is called Bell Labs. And Bell Labs was filled with researchers, a bunch of folks who had their PhDs and were paid good money to do research and figure things out with computers. Computers in the 70s, of course, were becoming a thing. And so AT&T wanted to leverage that. So they had a research arm that was figuring out how to best utilize computers. And that's where Unix came from. So Unix came out of Bell Labs. And all of these tools that we're using, awk, sort, tar, you go on and on and on, VI, the predecessor to Vim, all of these things came out of Unix, came out of Bell Labs. And of course, Linux has its pedigree because it's in essence based off of Unix. So that's where all that came from. I think probably the most remarkable thing to say about any of this is that they really did it right, because Linux is essentially, the origins of Linux goes back to the 1970s. And that is pretty incredible that an operating system that's so old is still so strong today. And all these tools we're learning right now in shell programming, right? All these things had their origins way back then. So they did a lot of things right because they proved to be useful to this day. Anyway, so enough of that. The awk has, we're custom in shell programming. We have a variable, we say something like var equals hi there, and then whenever we want to refer to the variable, we say $var, like we want to echo it to the screen or something like that. In awk, there are only a very small number of variables that are referred to in this $sign sense. And for all other variables, it is exactly how we're accustomed to using variables in C or C++, meaning I would just say var equals this, including the semicolon. And then if I wanted to print that out, then I would just do something like that. Or if I wanted to add, another string to it, you just refer to it naked. You don't use the $sign. The exception to that are these numeric variables. And awk is a tool that, like everything else, since it's a filter, right? When you're creating a pipeline, what you're creating is where, in essence, lines of text go, and things are processed by lines. So sort sucks in all the input and then sorts it line by line in order. Cut is cutting out a particular field for each line that it receives, right? So everything's line-based, and that's certainly true of awk. So when it's processing a line, it has these variables referring to the entire line, and then these convenience variables for the first field of the line, the second field, the third field. Let me jump down here and show you the format of it. Ignore all the comments. You'll note the comments in awk are just like comments in shell. The pound sign. So don't do that. That's C++. That's not shell or awk. The awk consists of these blocks. And a block is a Boolean expression that obviously evaluates to true or false. And then depending if this is true for the line that it's processing, it will execute these statements. And you can have as many blocks as you want. There's two special blocks, a begin block and an end block. The begin block is a block that is always executed before it processes any lines. And the end block is, as you would imagine, the statements that get executed after the last line has been processed. Let's see what that looks like. So there, let me look at the man page just for a moment. You'll note that in a typical usage, there's the command. You can actually embed the program right there on the command line. And again, this is a filter, so you could imagine this inside a pipeline where lines come in, goes through the program, and then they go out to standard out. Obviously, this is a bit easier on the eyes than cramming every single thing on one line here. So it isn't unusual to put larger programs into their own file, and this then becomes the most common option. -F to specify where it's going to get its program. So with that, let's say, let me copy. Well, need to copy Etsy password. Let's take a quick look at it. So here's our good old-fashioned Etsy password, 19 lines, nice and brief. So I will say first program off. And we need a Boolean expression. We'll say 100% of the time. What I want to do is I want to print the entire line. Now, just like C or C++, it uses semicolons at the end of statements. It is optional on the last statement of a block because there's no ambiguity there, right? You see the closing curly brace and you know you're done. So awk is a little more loosey-goosey, flexible with things like semicolons that have special circumstances. However, if you just kind of roll with it with what you're accustomed to and coding C or C++, you can't go wrong. So this will print the entire line 100% of the time. So I would say awk -F, first program. Now what I could do is I could certainly do cat Etsy password and pipe it in there. And that basically is just printing out every line, not doing much of interest. Otherwise, here I would specify the file that it is going to process line by line. Same thing. All right. What if I want to print out field 1? So this isn't going to do anything different because it considers basically the entire line field 1, and that's because the default field specifier, let's see, and I think I say that here, field separator, not field specifier, defaults to contiguous white space. So that means a series of spaces and tabs would separate one field from the next. And what we have in our Etsy password are colons separating. So what I want to do, these are, as it says here, these are built-in variables. This field separator variable, I want to change from its default to being a colon. And a good place to put that would be in the begin block prior to processing any of the lines. So I'd say that the field separator is equal to a colon. And now when I print out the first line, so awk -F, first program, Etsy password, I get then the first field. It's remarkable how much is optional in awk. This Boolean expression is optional. Again, I can have as many blocks as I want, right? So I have this block here. if I don't provide a Boolean expression, it assumes that this is true 100% of the time. So that one that I put was gratuitous. Let me just leave that off, run this again. For kicks, I'll do second field though. And there we get the second field. Also, the block is optional. So if I have that, then there's a default behavior for a block that I don't provide, which is to print out the entire line. And so there it goes, printing out the entire line. And so this isn't even needed because I'm not parsing anything. So that's a valid awk program, which is 100% of the time print out the entire line. Okay. One thing that is very common to do is to look for a regular expression in a line. So for instance, in the entire line, and it uses this operator, and then you put your regular expression in slashes. So let's say that if a line contains an uppercase character followed by another uppercase character, then what I want to do is print the entire line. And again, my default is to print the entire line, so I can leave the block code off. And this will just simply print out all lines that contain two uppercase letters. Let me clear the screen. Two uppercase letters next to each other. So that obviously fits the bill, and then this would fit the bill right here. So these two lines. If I wanted to only print out the third field, in that case, so there that is, third field of each of those. This, wanting to look for a regular expression on the entire line, maybe I want to look for it in a particular field. So let's see, what is this? 1, 2, 3, 4. That's the fifth field. So maybe I want to look for that in the fifth field. We should get the same output since it's in the fifth field of both of those. Anyway, this, looking for the regular expression in the entire line, is so common that this part is optional. So if it sees two slashes, it means look for this regular expression on each line. And if you find it, then do this action here. I've got a file. Two lines. All right. So I want everything between ABC and MNO. And here is the solution that's offered to do that, at least the one Google page I'd seen a while back, awk. And they embedded that. Again, you can put the program right in line, so that's what they did. They had it just like this, and we will pull this apart. So that actually grabbed all of the lines between those two, that short, tiny little thing. So let's see exactly what they did there. Let me take this, let me write this to, let's call this between, I might just call it two lines.awk. Two lines.awk. There we go. Okay, let's get rid of all that stuff. So here's our awk script. All right, so what this first thing to note is here they're setting a variable to 1. Now here's something that's wonderful about variables in awk. It's kind of like in the shell. If you need a variable, just create it, just use it, initialize it, and it'll come into existence, and it'll know the right type if you put a string in it. I believe internally it'll stores things as strings. You can even do things like counter plus plus, and I would never have had counter before that. What it would do is it would create counter, and it would initialize it to 0 and then add 1 to it. So awk is very, very forgiving in that sense. So what this is, the longhand version of this script is on the entire line, I want to look for the regular expression ABC. Now, if I wanted to make sure that ABC was the only thing on the line, you can always trick up this regular expression, meaning the line begins with ABC and that's the last character on the line, right? You can do any regular expression is fine there. In this case, it's just looking for that literal text. So if it finds ABC on the line, then what it's going to do is it's going to presumably bring this variable into existence and set it to 1. And then we see this here, which is similar to continue in C++. So in C++, I have for if I equals 0, I is less than 10, plus I. And then you might have an if statement here, if some condition continue, in which case it doesn't do any of this stuff down here. Continue means that it automatically goes back up to the top of the loop with the next iteration. It would do this increment and then continue with the body again. Okay. So that's what next is in awk. What that will do is that means don't do any more processing of anything below this point, meaning for the current line, don't do any of this stuff. Just go to the next line to process. So that's what it does. If it finds ABC, sets its flag to 1, goes to the next line. Now the next line comes along and the next line doesn't contain ABC. You can see it contains good 1 here. So nothing happens here. This is false. So this block of code doesn't get executed. Line 5 does not contain MNO. So it doesn't do that. But what it does is this. And what does this mean? Print line. Yeah. Again, the block of code is optional. So if you don't include the block of code, the default is to print the entire line. This is a Boolean expression. It evaluates the true. So that will print the entire line. So that prints good 1, goes to the next line. This is false. This is false. Prints good 2, prints good 3. And now we hit line 8. This is false. This is true. So it falls in here and it sets the flag to 0. Then we hit this and this expression is now false. So it doesn't do the default action of printing the entire line. And the rest of them, same thing, bad 1, bad 2, bad 3. They're at the lines 9, 10, and 11. None of these 3 blocks are true, so it doesn't do anything. And then you just remove this stuff so that you just get the default behaviors where possible. So the assumption is that will search on the entire line. So there's no need for me to specify that explicitly. And now I can go ahead and I can put all that, cram it together, even get rid of spaces if I want to be really tight with it. Put it in single quotes, awk, and then the process the line. So you can do some really powerful things with awk in very few lines of code. It's a wonderful tool to get familiar with. And you know, that's that's the goal of the whole course, is to give you enough comfort. It's fine to be unsure, but to give you enough comfort to go, yes, I know that this tool can do this. And if I just sit down and refresh my memory on a couple of commands, I can bust this out. Just overall, you'll just be so much more efficient in your life as a software engineer. Had someone take this course a couple summers ago who was in the security club and doing the that national cybersecurity challenge that folks go and do every year. And he said, you know, I easily earned our team an additional 5 to 10 points just because I had all these shell programming tools and I was able to take logs and pull them apart and in very short order. So yeah, this is good yummy stuff to learn. All right. Let me give you a real simple challenge then. So I've got this data here. Let me add it. Yeah, just these 5 lines. No worries. I'm just asking people to do this challenge, quick 5-minute challenge. Write an awk script that if it's an odd line number, print. I don't print odd lines, and if it's an even number, print the line. And your reference is going to be that file that I shared early in the chat. I know that maybe, I don't know if everyone got that 812. I guess most people got that. That was the awk format.awk. So here's the reference. These built-in variables are your friends here for doing this challenge. So I'm just going to give 5 minutes, not long at all. Shouldn't take you long. So NR is the number of the current row. So NR %2. When is that true? All counting begins, the counting for line numbers begins at 1, by the way, not at 0. So that is line 1.
Oh, that was the file you want us to use. Okay.
It doesn't matter. It doesn't matter which file.
Oh,
Any file.
It's true for odd numbers, because an even number would give you a 0.
Right. Okay. Good. So this is true for odd. And then if I wanted true for even, I could do and I don't. These spaces are gratuitous. Yeah, it looks nice though, so I'll leave them in there. Right. That would be true for even. Okay, and then I don't know what the challenge was. Let's see here. It's an odd number. Print. I don't print odd lines. And if it's an even number, print the line. So I just leave it like that. Give it a try. And doesn't matter which file, but I'll use this data.txt. So I have a PND. And there you go. Pretty straightforward. Let's do another one. We'll do it interactively. I won't force you into rooms to do this. This is going to introduce some stuff that I haven't necessarily talked about. Process Etsy password. So here's Etsy password. Print the fields of Etsy password in reverse order if it's one of the first lines. So this is showing that this is the normal order, and then the reverse order doesn't mean every character is reversed, but rather bin bash the last field, and then the penultimate field, and so on and so forth back to the first field. So we get these IDs at the end of the line. We want to print them in reverse order if it's one of the first 5 lines. Okay, so we'll call this reverse I guess I should make it the same name as the text file. Reverse challenge.awk. So the first thing that we have is our Etsy password deals with a field separator that's a colon. So I'm going to go ahead and do that. One thing to note about these curly braces for blocks of code, not to the begin block specifically, any block of code that you have in awk, is that here. All right. Some of us are accustomed, myself including, from writing a function like this, where I have the curly brace on its own line. That definitely does not work for awk, because if I do that, then what this is a Boolean expression with the default block, and then this is the default Boolean expression with this block, and the default Boolean expression is always true. So let me go back, and the default block is to print the entire line. So this is not a block corresponding to this regex. This is going to print the entire line if some regex is true, or I should say if that regular expression can be found in the entire line. And this will print, it'll do that 100% of the time because the assumed Boolean expression is true. So make sure that you have those married together so that this Boolean expression is tied to this block here. All right, so we set the field separator, and now we want to do an action if the number of rows, if it's the first 5 lines. So if the row number, the number of the current row is less than or equal to 5, then we want to do some stuff. And if you're in C or C++, how would you go about that?
Printing in reverse order.
Yeah, you use a for loop maybe, something like for. Yeah.
I decrement instead of increment from the end.
Yeah, very good. I would as well. So let me look at this, at my variables here. I have number of fields in the line. That particular line will have a certain number of fields. So I can start my counter being equal to the number of fields. And then as long as that's greater than 0 and I subtract 1 from it each time, then I want to print the field. Now note this. This looks interesting. And recall, oops, that's not a comment. Recall what has the $sign in front of it. The only thing that has the $sign in front of it is, there are these here, specifying either the entire line or a specific field. What's wonderful is it ends a variable, and if I put n there, it's the contents of that variable that is the subject of this expression. So this would be like $5, $4, $3, $2, right? Each the field's in reverse. That's extremely handy. So that'll do that. And then what I could do is I could then printf colon. Now I'll throw in some semicolons here. I'll put this entire for loop in curly braces. And then afterwards, I can go ahead and printf a new line after I'm done with the loop. Now note these parentheses here. I do that just because that's how I was raised in the C world, is putting parentheses around all this stuff, but it's not required. I believe it's not required. Now I'm confusing myself. Let's see, was there anything else to do? What if it's What if the row is greater than 5? So if the number of the current row is greater than 5, we just want to print the entire line, yeah, normally. So let's try that. Oh, got C function there. Get rid of that. And sure enough, we have those in reverse order. This is first, second, third, fourth, fifth, and then we go back to the normal order for 6 on. One little nitpick is that this last colon here shouldn't be there. So really, I don't want to do this 100% of the time. I only want to do this if n does not equal the last field. Try it again. And now we've got exactly that. I've omitted the colon there at the end.
What do you have? Oh, I see. Yeah, you don't have to use it. It's not bash. All right, yeah, that makes sense.
Right. Regarding, I guess one other note regarding that, the formatting here. Output field separator default is space. That's with a print statement. I've been using printf, but awk has a print statement, so I can do awk, and we'll just have this print $3, $2, $1. So print 3 fields in reverse order. And I'll do this with, well, I guess I can just echo a line into it. Echo, Larry, Curly, Mo, type it into there, and then it reverses it, Mo, Curly, Larry. Normally they're commas separating these like that. There we go. All right, so the OFS is the output field separator defaulting to a space. So as I separate all of those in the print, they're separated by spaces there. So I can add, let's say begin. I really could put it in the block I had, but I'll just put it in begin for philosophical reasons. I'll change that to be like QQ. So that's what the output field separator is when you're using just straight up print statements separating the things that you print with commas. You can change that separator between each of those that prints out. So that's what that special variable is. And let's see if I've covered everything in the notes here. This is what we did most recently. You can put a variable after the $sign and that'll convert to a number for the field number to work with. And stuff's optional. Yep, I think that about does it. So another wonderful thing about awk is it's easy to experiment with because you already know C++ for loops and things of that nature. So it's easy to throw together code based on what you know. It was originally designed to be very similar to C. Oh, there's one more thing. Associative arrays. Awk has associative arrays. do this again. So this is for so this is an associative array. Think of, you know, a hash or whatever. The thing to note is that, so this brings counter into existence, which is initialized to 0, and then increases it 1 and 2 and so forth. The thing to note mentally is that the key to the associative array is always a string. Even though I'm shoving integers in here, it'll convert it to a string, which means that this as a key is different than that as a key. So you just want to keep that in the back of your head, that this is always considered to be a string when it creates the associative array. So I can go through all the lines, and if the line is even, I can grab the first field, and I'll use Etsy password again, so that should grab that ID. And then after I've processed all the lines, what I'll do is I'll create a loop to go through this. And there's a different kind of for loop for this. So I can say for my key in my array, and I can print key equals my key. So now I'm using print, separating things by commas. Value equals my array. So let's try that. Alt head, Etsy password. That just shows me the first 10 lines by default. Tail shows the last 10 lines, and then you can provide options to get a different number of lines. Now, if I run this through the script, awk associative arrays.awk, and I want to go Etsy password, and I'll pipe that into head. Oh, what I got? Oh, this is my key. Let's try that again. Clear the screen. And then there are the first 10 lines, all the even lines, line 2, line 4, 6. Now you'll note that I have spaces here because the default output field separator is a space. We can actually just change the output field separator to nothing in that case. Let's do this. Output field separator is equal to empty. Now when I run that, so spaces. Okay, let's take a look at assignment 7. A7.tar, let me download that. Okay, so this tarball just contains 2 files, groceries.txt and receipt.txt. And let me go ahead and extract that. Groceries.txt. So what this contains, this is like, this is supposed to be similar to the data that the cash register might receive as the cashier is scanning in your groceries. And the first field, if I look at each one of these, is separated by a tab. So your field separator is a tab character. The first is the category. So air fresheners in the cleaner detergent, produce, apples are in produce, asparagus is in produce, and so forth. These number, the cost of these things I came up with somewhat randomly, so you'll find some offensive prices for some of this stuff. $7 for a can of tomatoes, for instance. All right. So what you need to do is your awk script needs to read in all of this information that this person has bought. And after you've read it all in, you need to print out a receipt. So your output to the awk script has to look exactly like this, meaning if you do a diff on it, there's no difference. Yeah. And here, so this header here would be a good place for, yes, in the begin block, right? You could put it in the begin block, or I suppose you could put the whole thing in the end block, just start out with that in the end block, either way. Here are each of the items and their price. Note that they're all a fixed width. So here's where we're printing out strings in a fixed width. So that's where you're using some of that printf stuff that you'll learn from the in-class exercise. See how far over is that? 30. Looks like it's 30 spaces exactly that each of these are printed left justified. After you've finished all the items, then at the bottom of the receipt, so everything you're seeing here is done in the end block, right? After you've read everything. Actually, this could be done as you read in each line. So as you read in each line, you can print out the item and its price, but you're storing stuff as well, because at the end of the receipt, so this would be in the end block. All right, so now I'm with the begin block. These are blocks as you're reading, but you're storing this information in like some associative array as well, because at the end, you have to print out subtotal by category, all the alcohol that was bought, so on and so forth. With the total. Little bit of tricky use of associative arrays to get this stuff to do what you want it to do. So that is what the awk assignment is.